This is a journey into space and time. Light travels fast, really fast. 186,000 miles per second. If you could travel at the speed of light, you could circle the entire Earth over 7 times in 1 second. The Moon is the closest celestial body to Earth. It is 239,000 miles away. Light takes 1.2 seconds to travel from the Moon and arrive to us. The Sun, however, is 93 million miles away, and the light takes 8 minutes to reach Earth. The reality is, you're looking back in time 8 minutes. This star, Alpha Camelopardalis, is 6,000 light-years away. You are looking at the star as it was, before the pyramids were built. The stars and the Sun rise and set like clockwork as the Earth rotates once every 24 hours. The night sky is full of celestial wonders. A long exposure photograph reveals more. These are nebulae, interstellar clouds of gas and dust. The nearest one to Earth is approximately 700 light-years away. Many nebulae are formed from the remnants of dying stars. Nebulae are often also regions where new stars are born. This is how the constellation of Orion looks with the naked eye. It's home to some of the brightest stars we can see. Photographic enhancement reveals more. This is the Orion Nebula, a gigantic cosmic cloud of dust and gas where numerous new stars are being formed. The Orion region is full of nebulae and cosmic dust. Earth is located in one of the spiral arms of the Milky Way. This arm lies about 2/3 of the way out from the center of the galaxy. We cannot see all of the galaxy because we are in it, but this is an artist's impression. All of the images shown so far have been taken inside of the Milky Way. The question is, can we see outside our Milky Way galaxy? Absolutely. This is the Andromeda Galaxy, which is the closest galaxy to our Milky Way. It can be seen with the naked eye, in non-light polluted areas. It's located about 2.5 million light-years from Earth, and its diameter is approximately 150,000 light-years. It's fair to say the numbers get mind-boggling. The image you're looking at was taken with a DSLR camera and a wide-angle lens. To the right is one of the spiral arms of our Milky Way. Point a telescope at Andromeda, and it's a completely different story. The Andromeda Galaxy is a remarkable cosmic entity that has captured the attention and imagination of astronomers and stargazers for centuries. It's twice the size of the Milky Way and contains around 1 trillion stars. This is the Triangulum Galaxy. It's about half the size of our Milky Way and approximately 2.7 million light-years from Earth. These bright, colorful blobs are nebulae within another galaxy. It's estimated that there are between 200 billion to 2 trillion galaxies in the observable universe. In this small region of sky, there are 255 galaxies. The scale and numbers are incomprehensible. Night conceals the world, but reveals the universe. Taking images of deep sky objects has many challenges. The target can't be seen and is constantly moving across the night sky. This telescope has been set up to overcome these problems. The target is selected in the computer software. The framing assistant allows you to frame the shot perfectly. An imaging sequence can then be set. The image duration can range from just a few seconds to a few minutes dependent on the brightness of the target. To improve clarity of the final image, several hours of images are taken and are later stacked in software. The computer will slew the telescope and automatically center the target. Focusing is done automatically. To prevent blurry images, a second telescope is used to monitor a star's movement. This helps correct tracking imperfections. This technique is called guiding. The whole sequence is fully automated. Light pollution is a problem imaging from city or suburban locations. Pollution filters can help, but there's only one real solution. These locations are reasonably remote, but are still affected by light pollution. Mobile imaging requires a mobile rig, or maybe two. These can't handle a heavy telescope, but still have all the functionality of a permanent setup. time-lapse videos were created with DSLR cameras and various lenses. This device is called an intervalometer. It plugs into a camera and controls how often, how long, and how many shots are taken. To prevent dew forming on the lens, a heater is fitted. For additional protection, the whole camera is covered. Running a camera and heater all night requires power, so battery banks are used. An all-night time-lapse can easily take 1,500 pictures. These are later joined together to make a video,